Hey guys, welcome to Michigan Machinists. I'm Craig, and I'm going to show you how to set up a CNC lathe. Hey guys, Craig here with Michigan Machinist. Today we're going to make a stainless steel pen, so let's get started. The first thing Ben does when a part comes in is he'll build a motto in Creo. Now we're starting with a simple one here. You wouldn't necessarily need a model in Creo for a part this simple. You could pretty much just generate what you need in Gibbs, but nevertheless, so he models the part and then he pulls it into Gibbs Cam. That's our CAM software where we generate the code for the tool path of the machine. So what he's done is selected these tools to use to cut the part. Those tools are in the library in Gibbs Cam. Those happen to correspond to the same tool numbers that we store in the machine. Now the carousel is only so big, so we do swap in and out different tools from time to time, but we pretty much use these tools in almost every setup. So right there he's just putting the center, putting clearance in the part. That's one program. We'll use the tailstock to hold that center. The next program, we'll turn the profile. And this is what that tool path will look like. And that's what the part will look like. Alright, so let's go to the machine and set it up. So here's what the pen will look like when it's finished. First thing we're going to do is head over and get the stock cut to size, and then we'll start setting it up on the CNC lathe. So this pen is 440 stainless. The 400 series of stainless is heat treatable. The 300 series that we typically use is not. And these have to get heat treated. So I'm just going to start by cutting a length that's roughly 2 feet. That way I can put it in the tailstock of the machine, put it in the chuck of the machine without hitting the tailstock. Wait for the coolant to come on. We'll quickly clean the burrs off. Now we'll head over to the machine. So we're going to run this inside a collet. So I'll find the correct collet. It's 1-inch stock. Right now we're just going to swap out the collets. So now we'll get the machine turned on and get the program put in. All of our other machines run on either USB or SD card. This one runs in the old floppy disk. This is not a 3D printed save icon, but it's a floppy disk. So we're going to open up the dinosaur here. Go into MS-DOS.
What version of Windows was that?
1.
Holy shit.
I'm not sure. Find our file names. So here's what our first program will look like. We're just going to turn a little ways to get past our tailstock and put a center in. There's our first program. This is our second program. So there's the first program. Second program. So this is the first program we're gonna run. We need an inch sticking out of the chuck. I like to take these and set up my stops. So the first one I'll set to 1 inch. The second program we're gonna run, we gotta have 5 inches of stop sticking out of the chuck. So we're gonna give just a little bit more. Alright, so we'll set the part for the first program. Set that to 1 inch. So this is what I was speaking to about the library of tools. This is tool 1. This geometry is stored in our CAD CAM software as tool 1, tool 2, tool 3, tool 4, tool 5. Kind of as it goes all the way around. It's a 12 tool carousel. Like I said, we do change drills and different boring bars and things in and out. So I'm going to double check his list just to make sure all these tools are actually in the machine. Tool 1, tool 3, tool 5, tool 10. All these tools are already in. We always use tool 1 to set the origin. Basically, we're looking to find the end of this face here. So I'll jog the machine down. I use a 1/2 inch gauge block to find it. Change that to fine tune where I'm at. Go into my work group. This gives me a value from this face to this face. The value I want is in the end of this tool, basically on the same plane with the end of the part. So I know that this tool is sticking out 0.204 from this face, plus I used a 1/2 inch gauge block, so the distance from this face to this part is 0.7404 inches. We use that for every program, 0.7404. So I'm going to take this value, subtract 0.7404, gives me this distance. I'll use that as a negative value since I'm moving in the negative direction. And that gives me the 0.7404. In other words, if I were to jog the machine over, to where this reads 0, you'll notice that this face is on the same plane as the end of the part. So now the part is taught, the correct tools are in, the program is in, we've set our origin, we're ready to run. Now I'm going to go and look at the program just to make sure that my proper tools are being called up, that I'm not moving too far in Z negative. So this direction is Z negative. If I have a line that's moving me past 1 inch in Z negative, I run the risk of hitting this. or hitting that and crashing the machine. So I'm just going to toggle through the program and make sure I don't see any Z values that are -1 or greater. This is a short program, so it won't take much. My correct tools are being called up. There's tool 1 again. My next tool should be tool 10 to put my center. Tool 5 is going to finish 1, excuse me. Program looks good. I'm going to approach it slow. I'll shut the coolant off so you can see my approach. That's Bob banging on the back of the machine to try to scare me because he knows I'm loading a new program. He's at about 100 thou waiting for the part. What I like to do here, now that I've barely kissed the front of the part, you can see that it didn't completely clean up, but I wanted to verify that it was in the right spot. I'm actually going to bring the stock out a little bit because the first thing it does is face it. So if I bring the stock out a little bit, we'll face enough to make sure that we clean it off. Now we've got a nice machine face for us to put our center drill in. Once again, I like to check the approach. Turn the coolant back on. Now we got a nice center drill. And now we're going to turn the OD. Finish is pretty good. Tool's pretty good. Now we're going to hit it with tool 5. One of the things I'm going to do on tool 5 is offset it out a little bit. What I mean by that, this is our first program. We relieved it, so when we bring our tailstock up, you'll see in the next program that we don't hit it. However, about this much of it in the second program is turned in the first program. So if I leave that out a little bit or leave it a little bigger, When I come in with my second program, it'll clean that up as it cuts this, instead of leaving a little mismatch there. So I'm going to go into my offset setting for my geometry for the X in tool 5. And I'm going to go 2 thou and input it positive. So now in the next program, I'll just remember to take that out so it'll be at the proper size. I can go back into my program. And that's my first program. Finishes a lot better. The reason why we use tool 5 to finish this instead of doing all the work with tool 1 is because we do light cuts with a sharper tool that we use for what we call a finishing tool. The tool will last longer, the surface of the part will be a lot more uniform, and really it just comes out with a higher resolution. So that's the first program. Now we're going to switch to the second program, which is 6680. So on edit, program, go O, 6680, O search, boom, program's brought up. Now we're going to do the same thing again. I'm going to have 5 inches sticking out of the chuck, so I'm going to comb through the program, make sure all the tool numbers are correct, and that we're not moving in Z negative anything over 5 inches. So I'll do that, and then we'll run this program. Pliers. They're Jackhawk 4000s. Available at Walmart. So this is what I set up this fancy stop for. We're going to be using the tailstock for this part. This is the tailstock. Now what I like to do is extend it. I'll come up and touch the part. I can kind of see where I am here and know when I bring this back. I like to give it about 1 inch overstroke, so I'll just make a mark like that. Come up about that far. Lock the tailstock down. Then I'll come up while I'm in place, touch the part. The reason I like to do that is because it centers it a little bit. But what it also does, since I'm in a collet, is it'll push the part back a little bit. But I like to do that before I set the 0. That way, if the part's going to move, it won't move once I have my 0. Tool 1's chipped out a little bit, so I'm going to go ahead and change it before we move on. And make sure you don't bump your tailstock. So we're going to do the same thing we did before. Got the value I want. always like to look at the finish, make sure I don't have any chatter. I didn't hear any chatter in the harmonics, so that means we're clamped good, supported good, and I don't have too much hanging out. So I went in that last program and I offset tool 5 out. I'm going to take that back out. Back to N2 is my second operation. Make sure I'm not going to hit my tailstock. Now we're going to measure that OD. .472. Tool 3 will come in here where this radius, where this corner meets that corner. It'll come in here and just cut that square. And now we're going to cut it off. And that's what one looks like. So now the back needs to be cleaned up. This center drill needs to be cut off and a groove needs to be put in it. So that's what we'll do next. So now that we made the pen, we have to put this OD groove in it. So we'll do that on the manual lathe. We were working on a big part here, so we had to flip the chuck jaws around. So right now I'm gonna reverse the chuck jaws so we can clamp on this part. We're going to put the OD groove on now. It's a fancy little OD groove tool. It's our safety stop. We'll set this up once we get in position. Make a little mark where I'm going to put a chamfer. And I know that's X.472. That's the diameter of the part. This needs to be 118. Plus 50 is 168. So it's a groove that's 50 thou wide, it's 118 from the end. Our tool happens to be 50 thou wide, so we can move over to 168. That puts us right where we need to be from the face. I'll always set my safety stop, that way I don't actually run into these chuck jaws with our tool. This part I'm going to slow the RPM a little bit. I'm bump my stop, and then just walk the tool in. $4.28. Looks pretty good. Just getting the burr off the top of it. Now we'll manually put a little chamfer on the end. Now this pen is ready to go out to heat treat. And we'll polish it when it comes back.